Hello everybody and welcome to another quick video. In this one, we are going to be looking at how does the DNS resolution process happens or work. So as you guys are aware that the DNS domain name system, given the domain, this is going to resolve and give you the specific resource record that you're looking for. And the most common and important one is going to be mapping the specific domain name into the IP address. So what we'll do is we'll quickly see what are the steps that it goes through in order to give you this mapping. So let's say this is you on your computer and you go into your browser and you want to reach out to a specific domain. Let's say this is example.com. What's going to happen is as soon as you want to reach out to this domain, a program called as a resolver, and typically this resolver is built into all of the operating system gets invoked, and this is going to send a DNS query to the local name server. So whenever I say local name server, just imagine this is the DNS server, and if you're an enterprise or organization, this would be your company's DNS server. If not, this could be the ISP's DNS server. And this local name server, it's going to check its cache. It's going to see if within the cache it has the mapping available. If it does, it's going to return that. If not, it's going to reach out to the root server. So on the internet today, in the world currently, we have about 13 root servers which are operated from different organizations, and these are geographically distributed all over the globe. And what the root server does is it's very unlikely that the root server is going to have mapping for example.com that you're querying, but instead this is going to have a list of top level domain servers that you can query to get the mapping. In this case, as you can see, we are looking at .com domain. So similarly, there are a bunch of other top level domain as well, like .org, .in, .uk, which is United Kingdom, so on and so forth. In this instance, the root server is going to give the local name server the list of .com DNS servers that it can query. So that would be step 3. In step 4, the local name server is going to look at that list and it's going to send the DNS query to one of the top level domain .com server. Much like root server, I believe we have about 13 .com servers that are geographically distributed all over the globe. And using Anycast, we will be sending the DNS query, or the local name server is going to be sending the DNS query to one of them. I believe for .org, we have about 6 name servers. For .uk, I believe this is 4 name servers that we can send query to. Now, much like root server, the top level domain server like the .com server, it's very unlikely that the .com server is going to have the mapping for example.com, but instead what it does is it's going to give the list of name servers or the list of DNS servers which are associated with example.com that the local name server can query to get that mapping, right? Would be step 5. And then finally, let's say in step 6, the local name server would query one of those name servers, which is given by the .com server. And these name servers are associated with example.com. And it's finally going to give back the mapping to the local name server. And typically, the final server which gives back the mapping, this is called as the authoritative server, and this is managed by the organization or the company whose domain it is. In this case, it would be managed by, if we are going for example.com, it would be managed by the company called example, right? And then finally, the local name server would send that response back to you. And then your machine would then know which server to connect to, right? So this is how the entire DNS resolution process happened. To quickly summarize, as soon as you want to reach to a domain, the resolver gets invoked, which sends the DNS query to the local name server, which is going to check its cache. If the mapping is available in the cache, it returns the mapping. If not, it would send the DNS query to one of the 13 root servers. A root server, unlikely this is going to have mapping for example.com, but it does have the list of top level domain servers that you can query. In this case, because we are reaching out to .com, it's going to send you the list of .com servers, DNS servers that you can send query to. So the local name server would send the DNS query to one of the .com name servers, and globally I believe we have about 13 .com name servers that can be queried. These are also geographically distributed all over the globe. And much like root server, it's unlikely that the .com server is going to have the mapping for example.com, but instead it does send you the list of name servers that are associated with example.com that you can send the DNS query to. And then finally, the local name server would send the DNS query to one of those name servers, which are associated with example.com. It's going to get back the mapping, and then it's going to send that mapping back to you, right? So this is how the entire DNS resolution process happens. I hope you enjoyed the video. Thank you so much for watching.